Cool. So, welcome to Sound Synthesis 2. This is the practical side of sound synthesis. So, we've done a bit of theoretical stuff last year. You're still welcome, as I said, to take the exam anytime you like, anyhow you like. You can rewatch that video for more details, but we can also chat about it if you're interested. If you want to do the exam in person, it would have to be in the next 4 weeks. And this class is scheduled for next 4 weeks. And then it's finished. So we have, we have booked 8 hours. We can push it a bit longer, see a bit shorter, whatever happens. And the exam for Sound Synthesis 2 is going to be application, so a piece of music. And I invite you to use SuperCollider and some stuff I will show you as the inspiration, as the actual backbone of the music. Okay, so you are allowed to render the SuperCollider sounds into a file. You're allowed to make the kind of music that your heart beats for. You know, it may be, I don't know, reggaeton, maybe traditional makam, maybe whatever is your true passion in music. I like to see that. You know, so it's not like, okay, you have to make noise music, you have to make this or that. What I'm trying to teach is a tool and advanced techniques. And I would like to see you use that in your own, department. So I imagine most of you will make something with a beat, maybe club type music, maybe some chill ambient, whatever you really like to do. Because I find it far too often that, there is little in terms of articulation if you work in a type of genre that you are not in love with. It's like, oh, I'll quickly do this, fade in, fade out, blah, blah, stuff like this. I'm not so much interested in this type of attitude. I'm interested in you guys actually, finding your passion with a new tool for the things that you already have passion for. Yeah, thanks if you close it. Because that's when it really starts to make sense. If you're like, okay, well, I know what I want to do. I guess, you guys do already. And it's a new tool more than anything. Okay? In terms of the duration, I mean, it has to be an interesting piece. Don't stretch it too long. If it's 1 minute only, it's not really a piece. Maybe 2-3 minutes is the minimum, maybe 5-6 maximum. Again, I'm not so much into the formalities. I'm really into what you guys are interested in and helping you advance. And if some of you says, well, I actually want to have a live thing, if that's your cup of tea, we can work that into the scheme as well. I mean, normally, actually, SuperCollider server, as you might understand, is one of the most, probably still. I mean, the server 3 is now unchanged pretty much for the last 20 years, I believe. It was about 2005. And it's still, the most efficient, the most DSP accurate thing out there, it seems. So it really has stood the test of time. And therefore, it is also very useful in live applications. I mean, if you're interested in doing, something in real time over 50, 60 speakers, SuperCollider, people will probably tell you that, it gets really messy in Max MSP, unstable in other environments as well. In fact, I can tell you in 2012, I was part of the design team. I was the interaction designer for the Coca-Cola Pavilion in London. And we ran SuperCollider, and it was 60, I believe, speakers and 60 sensors. And it was like, okay, let's see if it runs. We knew that if it doesn't run, we can always run it on 2 machines, client and server, spread the interface computation from the synthesis computation. But in the end, with the fast G5, what is this, 13 years ago, it just ran really smoothly, no problem. So it is actually one of those tools that, can stand. I mean, I guess they're not sending it to Mars yet, but we may do. So yeah, that's a bit of an intro. Any questions about this so far? Just the kind of the general stuff we're doing. Cool. You can always reach out to me. I don't know if you guys are aware. I mean, I do have an email which I check a few times a week, but the Hungarian students know very well that if they send me a messenger thing, that normally I voice reply within a few hours or even immediately. Because it's also the quickest way for me, just to see it. Oh, normally it's something short that I can explain in a minute or two. So if you have any questions, feel free to contact me directly, either messenger, either through email. Cool, so let's start the sound synthesis too. So, I mean, we've kind of scratched the surface of the theoretical chapters more than anything. So there is still quite a lot to discover, I imagine. You've seen the books. They're still out there for you. I imagine you didn't read through all the books. I have to repeat, your amount of learning is, of real learning, is largely dependent on these books. Those are the most accurate, comprehensive, concise at times, to the point sources of information, and everything else, including me and other YouTube content and tutorials and all of that stuff. All of that is, it was two fingers, right? all of that is secondary in value. So, print them out, buy them on, secondhand from somewhere, keep them under the, computer music journal, keep them under the pillow, keep reading these things. Also because not necessarily you need to know all the details, but to know what there is to know. To have a good understanding of where we're at, what are the techniques available, and so forth. So I will, again, I love this to become a conversation as well. So whenever I jump over something that is not very clear, stop me, ask the question. I'm happy to, repeat, go back, whatever. Now, in the first half, we were discussing theoretical chapters of sound synthesis, but actually what I would like to do now is get into essentially implementation side, slightly deeper things, I might say, that will hopefully help you develop a new and more appropriate intuition. Okay, so we typically rely on intuition in terms of art, and better so, in my opinion. But we have a huge scientific background. We have a lot of potential for systemic exploration. And this is excellent and needed, very needed, to expand your vocabulary. Right? So you are learning new words, new grammatical structures, new things, new options, just in order to be able to speak in the end. So that's what I'm also asking you to do here for the exam, not just demonstrate, okay, I can speak this language, let's call it that, but I can use it to say something that I really want to say. Right? So it is the actual use rather than demo. So we are hopefully gonna go beyond that. And in order to develop this deeper intuition, we're gonna have to dig a bit into the maths. Okay? It's nothing complex, really. We're not even going to go into complex numbers. Worth noting is that in signal processing, there is a whole field called quadrature processing. And quadrature processing is complex numbers math. Complex numbers are numbers that consist of two values. To put it simply, you can plot them on a 2D XY plane and so forth. And it gets a bit more challenging to understand these things. So there's definitely things that we're not going to even try. I'm just going to mention it. And then maybe, if your career takes you there or interest, I've heard of this. Okay, I know what it may be about. So I'm going to actually dig into some basic maths without doing the math. But just to see it, just to hopefully understand how these numbers really do their thing. Okay? Now, the first important chapter is range conversion. Okay? So typically in our signal processing implementations, we are dealing with signals, which is a signal over time. It's fairly straightforward. And typically, we know the exact range of these signals, which means the minimum and the maximum value. Okay? So you're probably aware that most digital oscillators go between -1 and +1. This is the range. The actual output through the sound card is also limited at -1 and +1. That is the range of the signal. But in the meanwhile, you know, in designing things and in understanding how things work, it will be very useful to figure out range conversion and understand it, and also curvature. Okay? Now, I'll try to test so can anyone tell me how would you do range conversion? Let's say I have a signal between -1 and +1, and I want it to go between 100 and 200. How would we do this? You can tell me, I mean, even if you just know an object name in max MSP, it's a good start, you know, get it going. Or if you've seen one in SuperCollider, or if you can tell me the math operators needed, or if you can tell me the actual equation. Any of this. Is this a bit difficult? I mean, I'm just testing, you know, so I know how, you know, where I need to start the introduction. So I'll start at the very beginning, yeah? Okay, so the way I like to present this is such that you intuitively grasp it. So I'm not going to draw the equation and say, well, if you solve for two variables, maybe this kind of rings a bell, solving equation for two variables. It's not, we're in the art school in the end, right? So the first thing I would like you to embrace is the idea of the size of a range. Okay, so if and the way I see the size, well, I can see it on the axis and like, okay, from minimum to maximum, that's the size. And if I want to express it with a number, any idea what do I do? So what is the size of range -1 to +1? 2, exactly. So how do I calculate this? I mean, obviously, you know it's 2 because you kind of visualize the axis -1 +1. There is 2 steps, right? What is the math behind this? How do I get to number 2 from these two numbers? It is maximum minus the minimum. So it's +1 minus -1. And maybe you remember from school, -1 is +1, so it's 1 + 1, so it's 2. Okay? So what is the size of the range between 100 and 200? So 100. Yeah, exactly. So +100 + 200, range is 100. Okay? So this should kind of make sense, right? So we are figuring out the size of the range based on the maximum and the minimum. Okay, that's our first step. Now, in doing range conversion, what I propose as the most straightforward thing is you first adjust the size from the source range to the target range. Okay, so we stick to the same example. Our source range is -1 to +1, which is 2. Target range is 100 to 200, which is 100. Now, the way you grow a range is by multiplying. Okay, the way you shrink, well, you can multiply with the number lesser than 1, or you can divide with the number larger than 1. But in any case, it is multiplication. Okay, so for the first step will be multiplication, which will take care of the size, right? So I already know that my source size is 2, my target size is 100, so the multiplier is 50. Yeah? First step done. Okay? Source range size, target range size, and how do we get to 50? If it's on paper rather than intuitive, you divide. Yeah. So you take the final range, the target range, you divide by the source range, 100 divided by 2 is 50. This is our multiplier. We have the multiplier for the range conversion, and we have adjusted the size. Now, once we have adjusted the size of the range, what we do is we shift it. So we now know it's good size, it will fit well, but it's not offset yet, right? It's not shifted yet. So we have to figure out how much we need to shift it by. And shifting works with addition, right? Because if I add the same number to minimum and maximum, both will shift by the same amount. So by adding values, the size will not change. Is this a meme by now? I can do the size changing, right? So that's the two steps. First, size, and then the shifting. Okay, so how do we figure out the shifting amount? Well, we actually take the intermediate step. So I already know that 50 is my multiplier. And if I use this multiplier, my intermediate range, I shouldn't say intermediate, intermediary, I guess, the halfway range, right, will be how much if I multiply by 50? Minus 1 times 50 is minus 50, plus 1 times 50 is plus 50, right? So actually I already verified that the size is okay. I see that the size is again 100, but you see that it's not 100 to 200. I have to shift it up by how much? So minus 50 has to go to 100 plus, and plus 50 has to go to 200. So you already actually see that you can verify the step here because both have to be true. So the amount to add is 150, right? And then what you can do, so now I have it. Now I know that my multiplier is 50, my adder is 150. So in order to verify my range conversion, I can take the source minimum and do the math. So I take minus 1 times 50 minus 50 plus 150 is 100, works. That's the target minimum. I do the same with source maximum. Source maximum is 1 times 50 is 50 plus 150 is 200. Spot on. That's my target maximum value. Good. We got there, okay? So I've done this almost deliberately, just verbally. You know, because I like you to develop these things. You know, it's not the kind of thing that I'm trying to teach, which is, okay, if you can do this well, then you've done it. Because then I would actually focus on you doing it and I would present it, you know, in steps, visually, 3D animation, just because this is important to understand. The point is that this is not important as a target. This is important as a step, as an internal step for you to start thinking in this manner. Okay? Now, let's try to solidify this. So I will give you this as a task just to see how fast you are or if you get stuck, and give me the opportunity to talk about it again. So I will say that my source range now will be between 1 and 10, and my target range will be between 1000 and 2000. Okay, and my question is, what is the multiplier? And my question is, what is the adder? Okay, so I've got these pieces of paper. I'll give you a few minutes. I'll pause the video.
Is the multiplier float down there?
So let's see. No, it's not a float. So what was the first step?
The
Size of the range.
Yeah.
Okay, so what is the size of the range here?
9.
9, excellent. Size is 9. And what is the size of the range here?
1000.
1000. So the multiplier is?
1000 divided by 9.
Exactly. 1000 divided by 9. Oh, is it floating then?
Yeah.
It is,
One-
sorry.
1.111.
Exactly. So there we go. It's a valid number, I guess. Okay, so now comes the adder, and maybe that's why it's tricky, because it's a floating point. So what was the recipe? How do I get to the adder? I need to figure out halfway range. right? So I'm pretty sure about the multiplier. So now I have to substitute the multiplier into the range conversion. And what I figure is that my intermediate range, so let's call it halfway range, will be 111. I will truncate it there, because 1 times 111 is 111. And my top maximum, source maximum, is 10 times this will be 1111. Again, I've truncated, right? So what I've done is I've taken the source minimum times the multiplier. I've taken the source maximum times the multiplier. This is my halfway range.
But 10 times 111 would be 1110.
Yeah, I'm truncating that. I mean, here I've truncated one earlier, here I've truncated one later. It's not a big deal. It's not an atom bomb, you know. I mean, unless the tune really, you know, blows, so to speak. But typically, you know, we are mostly about getting the thinking process. So this is my halfway range, and from here I should be able to figure out how much do I have to add to get to this range. So here I already see that the size is okay, it's 1000. So the size of the range is great, it's just that I have to offset it by how much? Well, I can do the math, because 1000 minus 111 has to be the same as 2000 minus 1111. And in both cases, this is 999. Am I right? No, 899, yeah? Make sense? 889. Better. Okay, and now I can test it, right? So I can say my source minimum is 1. I do times 1000. Sorry, I do times 111. And I add 889. And I got 1000. And I should be able to do the same with the top of the range, which is 10. And, well, I'll add in the 1, just to make sure I'm cheating. Oops. Sorry, 10 times... Yeah, I wanted to add 1 more here, just to make sure I'm cheating. And that's that. Okay, got it? Cool. Now, source range. So I'm gonna erase these because these are the results. I want you to do one more, okay? Just because now you've started it on your own, we finished it together. Let's see if you can push through the whole bit here. So source range will be minus 5 to plus 5. Okay, well, I'll leave the step here. But the target range now will be between 2000 and 1000. Let's see if you can figure it out. Okay? So what we can call this is inversion, right? So in the source range, we go from lower number to higher number. And in the target range, we go for higher number to lower number. So we actually expect the whole range to flip. So minus 5 has to become 1000, and plus 5 has to become 2000. If it's truly painful, just do the normal one, 1000 to 2000, or maybe start with that. And then we can also talk about the range inversion, how it would work, okay? Take a few minutes. Okay, so I will do the simple one first, okay, and then give you a bit more time to see if you can figure out the second one. So this is size 10. This is size 1000. Multiplier 10, right? Halfway range.
No, 100.
Oh yeah, true. Thank you. So halfway range, minus 500 to plus 500. Makes sense? Which means I have to add 1,500. True? Excellent. Now the second one, I can give you a hint. Did anyone figure it out? The hint is, yeah? The hint is that the multiplier is negative. Right? So actually it's the inversion is part of the size game, so to speak. So as I control the size with the positive number, right? Larger than 1 gives me larger, smaller than 1 gives me smaller, but if I go below 0, then you start to get the inversion. So if I actually multiply a range by minus 1, right? Then actually it becomes the exact opposite. I mean, it depends if it's unipolar, bipolar, right? If I have a range minus 1 to plus 1, I multiply by minus 1, the range stays the same, but is inverted. So if you have a bipolar range, meaning both negative and positive, then you can actually get an inversion with single multiplier. How do I invert the range between 0 and 1? So I have a range 0 to 1, and I want it to go 1 to 0. I just want to flip it. How do I do it? Well, you know it has to be minus, right? You know that the size is the same, so the multiplier has to be 1, so the multiplier is minus 1. So you do the intermediate step. 0 times minus 1 is 0. 1 times minus 1 is minus 1. So the offset is 1, right? So if I take 0 to 1, I multiply by minus 1, I get this. 0 to minus 1 and inverted. And then I just do plus 1. And then I'm having the same original range, but inverted. Okay? So let's see if you can do this one. I'll give you a minute or two, now that you know that the multiplier. So, size is 10, source size 10, target size 1000. So actually the multiplier is the same, right? Only negative. Agreed? So multiplier is minus 100, and then I can figure out the halfway range. So minus 100 times minus 5 is plus 500, and plus 5 times minus 100 is minus 500. So I get the range 500 to minus 500, just as I got it here, right? So how much is the other? This needs to become 2000, this needs to become 1000. The other is the exact same thing, it's 1500. Make sense? Cool. So, you know, I think it's what I'm really after is you guys having a sense of what's going on, rather than, you know, you won't do an exam with doing math like this. It's not the point. In MaxMSP, you have the object called scale, which would do something like this. You specify source minimum, source maximum, target minimum, target maximum. It does the math for you. In SuperCollider, UGens will respond to dot range method, which will take into account the source target already, sorry, the source range already, which means that you only need to specify the target. Okay, I'll show you this briefly. So in SuperCollider, if I will do a very slow control rate thing so we just see the numbers. Okay, so I'm going to take a sine oscillator at 1 Hertz. Okay, if I poll it, then I should see the numbers. Probably need to boot the server. It's active. No, server is not active. Server boot. All right, so if this happens to you, it means that there is different sample rate for inputs and outputs, which is a problem. So let me just fix that. Hide audio devices, were they visible? Here we go. So in this case, I have 44 and 48. That's why it's complaining.